Good afternoon. On behalf of my co-authors, I'm pleased to be here today to talk about semantic artificial intelligence, which we believe holds key promise in the global effort to improve biodiversity monitoring and reporting. I think many, if not all of us that are at this conference are at the same time highly supportive of the kind of monitoring and reporting framework shown on the left side of the slide, and frustrated that today's state of the practice isn't getting us to the reporting systems we need in the face of highly siloed and diverse data. So despite the fact that we have many public data and code repositories, tools to maximize their machine actionability, LLMs, and disciplinary metadata standards, we still don't have the capability to seamlessly integrate this information and build up these reporting standards in a way that can really make them highly credible and timely for decision making. What might be able to solve this problem? I'm going to describe some work I've been working on with colleagues for close to 20 years on a project called ARIES, Artificial Intelligence for Environment and Sustainability, which combines community-endorsed semantics of machine interoperable, multidisciplinary data and models, a federated system of worldwide data and models, semantic orchestration by AI, specifically through machine reasoning, and a digital twin technology that supports near real-time updates. Let's start with the metadata, and we want this metadata to have semantics attached to it that describe its content and do so with the logical consistency that AI needs to move beyond just discoverable and accessible to fully interoperable and reusable. So the semantics we use combine the formal precision of ontology with the clarity of natural language. They're explicitly designed to be semantically explicit and machine readable, and to work across interdisciplinary data and models, to be understandable by experts and yet compilable into logical formal statements. We believe that since biodiversity and all of the associated data that go into these reporting frameworks do cross multiple disciplines, that it's important for these semantics to be agnostic in terms of the disciplinary terminology they adopt. And by doing that, they can provide a sort of semantic glue for knowledge integration. We do this by using a common core ontology that describes the fundamental pieces of scientific measurement, reusing existing community-endorsed vocabularies and ontologies whenever we can. We do so in a way that defines causal and compositional relationships between different concepts from different fields. And we also realize that often experts are going to want to be able to crosswalk back to their preferred terms, so we support that crosswalking. All of this leads to machine reasoning, which we see as a complementary AI paradigm to LLMs and machine learning if it's built on rigorous semantics. And this improves on some of the more glaring problems of LLM and machine learning-based models, namely their transparency, replicability, and full provenance, which machine reasoning supports. And so the reasoning algorithms contained in ARIES support a multi-criteria analysis that allows a computer system, when faced with a particular modeling problem and a set of data sets and models that could solve that modeling problem, to evaluate which data sets and models may be most appropriate based on criteria like fit for purpose, the spatiotemporal match of the data to the problem of interest, how locally specific the data and models are versus more generalized, say, global models, and other user-specified metrics. All of this lets the machine reasoning-based algorithm combine, execute, and provide reporting and provenance based on the best available data and models for a problem of interest with a high degree of transparency, and transforms our scientific knowledge from a static resource to dynamic, durable, and fair computable resources. While this is a tall order, there are many communities that have started in a fragmented place and have come together to adopt and build the sorts of standards that could facilitate faster and more transparent, high-quality global biodiversity monitoring and reporting, such as genomics, the Internet of Things, and the climate and agricultural model intercomparison communities. So we hope you'll be interested in this, learn more, and join us. There's a QR code to a recent paper of ours that describes this approach in the community we're building, and we'd be thrilled to talk more with you if you're interested. Thank you so much.